Hi, my name is Bruce Daube. I work in Steve Lofty's group at Harvard University, engineer in the group. And for the HIPPO campaign, we have two instruments on board. An older CO2 instrument, which we'll describe in more detail, and the QCLS instrument, which is a relatively new design by us. That one also measures CO2 in addition to CO, methane, and N2O. But for today, I guess we're going to talk about CO2 instrument. This is something that we built back in 1996, originally for balloon campaigns. The CO2 instrument draws air in through a rear-facing inlet in one of the HIPPOs, which we'll go over and take a look at. There's one hanging on the bottom of the plane. It's easy to see. Rear-facing, so that we don't draw in too many water droplets as we fly through clouds, or also avoiding large aerosol. We filter the air as it comes in, just in case there's some things left in there. And then we run through a permeable tube, a Nafion dryer, which removes the bulk of the water vapor. But then we also go through a dry ice cooled trap to get the rest of it, so we get the dew point down to minus 70 C or so, minus 80, to really dry the air. The things that we need to worry about is keeping that water trap cold. We have to restock with dry ice at each stop, and we also have to periodically remove the trap and warm it up and blow the water that we've collected out. And for the CO2 instrument, we normally do that about every 3 flights. One of the things with CO2, in the stratospheric configuration, we would measure CO2 with a precision of about 0.03 ppm. The background level now is somewhere around 385 ppm, so it's a pretty precise measurement. One of the really important things for most flight instruments is to do in-flight calibrations, and so we carry 4 cylinders in the instrument that we use during the flight, where we zero, and we also measure a low concentration, low span, high concentration, high span. And then the 4th bottle we use as a check of the calibration occasionally during the flight, and compare what we derive from the calibration, what we think is in that tank compared to what we measured in the tank prior to the campaign. And that ultimately serves as a real good quality control of how well the instrument's working. You asked about the dry ice. We also have to worry about keeping these gases filled, and we don't like to let them run down below about 500 psi, because below that you start to see a small change in the concentration that comes out of the tank. So we do have cylinders in Christchurch for refilling tanks if need be. Fortunately, we've managed to get our gas flows low enough now that actually for everything on board we're usually able to make the whole trip without refilling, which is nice, because we like to cal before the campaign and after the campaign in the lab. We can't do it on the way during HIPPO, and so if we have to change the gases in Christchurch, we lose the after cal for the first segment and the pre-cal for the second segment. We still have before and after, but it's nicer to have both. So we bring the air into the instrument, and we have a pump on the front end that increases the pressure of the flow. From outside, we go anywhere from actually over 1 atmosphere. Because of the way the inlets are configured, the pressure is a little bit higher than sea level when we do the low altitude legs. And then down to 760 torr at the surface, down to about 50 torr outside, or not quite 50 torr at the high altitude leg. And so a large pressure range to operate over. We use the pump to bring in the sample air and deliver it to the instrument at a fixed pressure. And we actually have 3 different levels of pressure control to really make sure that things are stable. So we don't collect anything. We just come through, look at it, measure it, and then send it on its way. And the nice thing about that is you have the number already, as opposed to collecting samples on board in flasks or whatnot, where then you have a lot of lab work after the fact. If you want, we could take a closer look at the HIPPO and maybe the instrument itself on the plane. So this is a HIPPO, inlet side, outlet side. You can see it's capped at the moment. During flight, the caps are of course off, and inside there are 3 tubes, and they can be configured in different ways. For our purposes, we have one of the tubes down inside that comes, it's a 1/4 inch stainless steel tube, bent backwards so that it's rear facing. So air flows through, increases in pressure a little bit on the inside due to the constriction on the outlet, and then continues on its way. So we just pick off a little bit of sample air from that and run it up into the instrument. Other instruments share a HIPPO, so you have to be careful with to make sure that if one instrument has a leak and is leaking cabin air back into the HIPPO, it creates a problem for the other people, potentially it creates a problem for the other people who sample from the same point. So you have to be real careful, take care of each other by making sure you don't have any cabin leaks into your inlet line, because of course at high altitude the pressure outside is quite low, the pressure inside the aircraft is more like equivalent of 10,000 feet, and you need a lot of pressure to push cabin air into the inlet tube, which is a disaster when it happens. So from the 16th inch stainless tube inside the HIPPO, we have a junction inside under the floorboards. We can open a hatch to get at, and we have a piece of Decron tubing, plastic tubing, that comes up a couple of meters up to the instrument in the aircraft, and connects right where we have an inlet filter. All right, on the forward end of the instrument, relative to the aircraft anyway, we have the dry ice cooled water trap, which gets filled up every day before the flight, and you can see the sample in and out tubes and a vent as well, so that the CO2 vapor is vented in a controlled way. The inlet is difficult to see, but the tubes that we mentioned coming out of the HIPPO, one of these tubes comes up and actually goes into the inlet filter. It's tough to see, and it's a little bit tough to change, so fortunately we don't have to do it too often. On the upper portion of the rack is a RAF CO instrument, also part of the HIPPO campaign. Okay, so one difference of using this instrument on HIPPO is that normally we use a pressure trip to turn on the instrument, so when we take off, pressure decreases to a certain point, the instrument senses that and turns on automatically. In this campaign, we want to turn the instrument on more manually, so we have some switches here which we can use to start the instrument sampling as soon as we start to taxi, and then we get a sample, we get measurement right from the ground up. We mentioned the air coming in the HIPPO, and it comes through the instrument, comes back out of the instrument, and finally ends up getting into the exhaust manifold on the plane. And this runs the length of the plane. Many instruments discharge into it, and it exits out the back of the aircraft. So that's about it for CO2.